Okay, so we are here. I'm just about done with 4.8 actually. Okay, so I'll definitely finish 4.8 by tomorrow, but maybe even today. So I have all of next week to do 4.9. So aim to finish 4.9 by Wednesday, Thursday question and answers, and Friday's a test. Okay. Tomorrow's quiz. I'm going to give you stuff involving half angle and double angle formulas. So stuff like page 244, double angle formulas, sine of twice an angle, cosine of twice an angle. So we had homework problems like that. Okay. And also the half angle formulas. Okay. So they can be written either this way or this way. So sine squared of x equals 1 minus cosine 2x over 2. Cosine squared of x is 1 plus cosine 2x over 2. Okay, so quiz will be questions mostly like that. It's 4.7 material. Okay, and yeah, this is good. Stuff that looks very much like this, I would say. Okay, so the closest problems to the quiz would be 4.7, page 250. Stuff like this. Okay, so I'll give you something like this. I'll tell you where you are, and then I might ask you find, all of this stuff. Cosine of twice the angle, sine of twice the angle, cosine of half the angle, sine of half the angle. And now, of course, if they give you only one of these, you can always, like if they give me only cosine, you can always find the sine, and vice versa. If they give me the sine, you can find the cosine, right? Because you have the identity that sine squared plus cosine squared equals 1, right? Basic trig identity. So you can always use these if necessary. It's on page 239, stuff like that. Okay, and you know the way quizzes work by now. I don't think I have to tell you what it's the same as always. I'll break you in your breakout groups and do 9-10 on Monday. Okay. And by the way, this weekend you actually get 1 more hour to do the quiz because daylight saving is over, right? So what is it? Saturday night, we fall back 1 hour, so you actually get 1 more hour this weekend to do the quiz. Is that right? Okay. So tomorrow's quiz will be stuff that looks sort of like this. Okay. All right, so I'm going to get back to 4.8. Okay, so homework-wise, we're up to here. As usual, for the next exam, you're turning in all of this stuff a week from tomorrow, right? And then we have 2 tests after that. This is very short, and this is still kind of short compared to what we just had. Okay. Okay, so 4.8. I did a lot of these problems. I'll do a lot more, right? Okay, so I'll start you off with, say, 27. And I was just going to do 27 and show you how to do most of the rest of these. Okay, 27. Arctan of tan 7 pi over 6. Again, these problems are a little bit deceiving because at first glance you might think, oh, just cancel the arctan and a tan. The answer is 7 pi over 6. It's not quite that easy. Okay, for arctangent has to return an angle between negative pi over 2 and pi over 2, we said. So we can't have this. Now, we could actually figure out what the tangent of 7 pi over 6 is, but you don't have to. Okay, and I'll show you why. Okay, here's 7 pi over 6, right? I'm going to go back over here to pi over 6. They are pi radians apart from each other, or 180 degrees. Okay, so this is pi, or 6 pi over 6. So I go another 30 degrees, and by symmetry, that's 30 degrees. Okay, now, this is in the first quadrant, this is in the third quadrant. Okay, they are reflections across the origin. So if this is the point x comma y, this is negative x, negative y, right? In other words, the positive x here will match the negative x here, and the positive y going up this way matches the negative y going this way. So if this is x comma y, this is negative x comma negative y. You could actually work this out. Okay, it turns out to be what? Radical 3 over 2 comma a half. You don't even have to write that down if you don't want to, and you can kind of tell I'm not even bothering to write it down because you don't need it. Okay, but whatever this happens to be, this is the exact opposite. So the tangent, remember tangent is the ratio of sine to cosine, or y to x. Okay, so I have y divided by x. The tangent of 7 pi over 6 would be negative y divided by negative x. But negative y divided by negative x is the same as y over x. In other words, what I'm trying to say is that the tangent of 7 pi over 6 matches the tangent of pi over 6. Okay? And you probably notice I'm not using my calculator for any of these homework problems so far. We haven't needed it. Now, the next section, section 9, where we have law of sines and law of cosines, you have to use a calculator. But for so far, all the problems that we've had here, no calculator necessary. You should be able to analyze it without a calculator. Now, of course, I'm letting you have a calculator in any quiz and homework and test, so you can use that as a double check, but you can't use that just as your primary answer. You should analyze it, like we're doing here. Okay, so anyway, I'm claiming tangent of 7 pi over 6 and the tangent of pi over 6 are the same. And because arctangent, inverse tangent, comes back with an angle between negative pi over 2 and pi over 2, negative 90 degrees and 90 degrees, pi over 6 is in there. Okay, so that means I can now say arctan of 10 pi over 6 is pi over 6. Okay, so one more time, I'm replacing tangent of 7 pi over 6 with tangent pi over 6 because they're equal. The ratios are equal. This is y over x. This is negative y divided by negative x, which is the same as y over x. So instead of writing this, I write this. And now that arctangent comes back with an angle between negative pi over 2 and pi over 2, which pi over 6 is, I can just now say the answer is pi over 6. Okay. All right, so that's it for that one. Now, for problems like 29 and on, I'll show you another way to do these. Okay, so I'm going to go back to our right triangle trigonometry. Okay, so recall we did this, right? So I made myself a triangle, right triangle, theta, opposite, hypotenuse, adjacent, right? And then our SOHCAHTOA, some of you have heard of that. Some of you say, what is SOHCAHTOA? Sine of theta is opposite over hypotenuse, SOH. Sine is opposite over hypotenuse. Cosine, CAH, cosine of theta is adjacent over the hypotenuse. And TOA, TOA, tangent of theta is opposite divided by adjacent, right? Okay, so I'll use that to analyze how to figure this stuff out. Okay, so starting with problem 29, they mix up more than one trig function, like cosine of arcsine, and how do you do that, and cosine of a sum. So I'll show you how those work now. Okay. All right, so cosine of arcsine 4/5. I'm going to temporarily call this theta, right? Because I don't like cosine of all that stuff. Let me call it theta. So ultimately, I'm trying to find cosine of theta, right? If I rename this as theta, I'm trying to find cosine of theta. Okay, now theta is arcsine 4/5, right? You rewrite it without the arc. I'm taking the sine instead of arcsine. Am I taking the sine of 4/5? No, I'm taking the arcsine of 4/5. So I must be taking the sine of something else. There's only one else, theta. So sine of theta equals 4/5. Okay, find cosine theta. Now you can use your identity, sine squared plus cosine squared equals 1. That would still work. Let me show you the right triangle trigonometry method. So I draw myself a triangle, put theta. Sine is opposite over hypotenuse. So from here I go opposite, 4, hypotenuse, 5. Okay. Then you can do your Pythagorean theorem, a squared plus b squared equals c squared, to figure out this. It's 3. Maybe from trig, you might recall the 3, 4, 5 triangle. Have you ever heard of the 3, 4, 5 right triangle? 3 squared plus 4 squared equals 5 squared. Or just do your Pythagorean theorem, right? 5 squared is 25. 4 squared is 16. 25 minus 16 is 9. Square root of 9 is 3. All right, so I got the whole triangle. Now I want cosine of theta. So cosine is adjacent over hypotenuse, CAH, right? So adjacent over hypotenuse would be 3 over 5. So my answer is cosine theta is 3/5. Okay, so that's another way you can do this kind of problem, other than doing your cosine squared theta plus sine squared theta equals 1. That would still work. You could still do that. I'm trying to show you another technique because maybe some of you like this better. Okay, try another one like that. 33, cosine of arctangent of 4. Okay, so 33. And yes, you might be thinking or snickering behind the scenes, hey, he's doing a lot of the homework problems. Yeah, I know, and that makes it easier on you guys. So again, there's really no excuse for not getting at least the 70% homework requirement. I end up doing, what, half of it, maybe sometimes even more than half, maybe a little bit less than half. But even though I say 70%, you don't really have to do 70%. You end up doing much less. Of course, you should go back and review it for exams and so on. Okay, call it theta. So ultimately, I'm trying to find cosine theta. All right, so theta is arctan of 4, which means tangent of what? Am I taking the tangent of 4? No, I'm taking arctan of 4. I must be taking tangent of theta. So tangent of theta is 4, but think of it as 4 over 1. 4 over 1. Tangent TOA, opposite over adjacent. Okay, so I drew myself a theta. Opposite is 4, adjacent is 1. Do your a squared plus b squared equals c squared. You get the hypotenuse is 17. Okay, what's 1 squared? 1. 4 squared, 16. Add them up, you get 17. So the hypotenuse is radical 17. Okay, once again, you want cosine. Cosine is what over what? Adjacent over hypotenuse, ca. Right? So the adjacent over the hypotenuse is 1 divided by radical 17. And here we go. Okay. So that's it for that one. Okay, 35 is much harder. Cosine, arcsine 3/5 plus arc cosine 4/5. Okay, that looks pretty scary. What you want to do is temporarily call this and this, let's say A and B. Because we have a formula for the cosine of a sum, cosine of something plus something. Okay, cosine, arcsine 3/5 plus arc cosine 4/5. Okay, so I'm going to temporarily call this A and B. So I have cosine of A plus B. I have a formula for that. Okay, right here. Cosine of A plus B, cos A, cos B, minus sine A, sine B. So once I figure out what all these things are, then I'm good. Okay, and you can put these formulas right on your cheat sheet. All right, so now I'll analyze A. A is arcsine of 3/5. Write it without the arc. So sine of A equals 3/5. Again, you're not taking the sine of 3/5. You're taking the arcsine of 3/5. So you must take the sine of something else. What else is there? The only thing else is A. So sine of A is 3/5. Do the same thing over here. I call this B. B is arc cosine of 4/5. Okay, so how do you write it without the arc? Cosine of 4/5? No. You're taking arc cosine of 4/5. You must be taking cosine of something else. The only else is B. So cosine B is 4/5. Okay, so if I relabel this as A and this is B, I'm taking cosine of A plus B, and I have a formula for that. All right, so I do my triangle. So here is this triangle. Sine is SOHCAHTOA, opposite over hypotenuse, right? So I draw theta, I go opposite hypotenuse, 3 5. Okay, this is 4. It actually is worth memorizing, in my opinion, the 3, 4, 5 triangle, right? If you have a right triangle, sides 3 and 4, the hypotenuse is 5. 3 squared plus 4 squared equals 5 squared, right? 9 plus 16 equals 25. So, yeah, sine of A, opposite over hypotenuse. So that makes this 4. So what's the cosine of A? Adjacent over hypotenuse, 4/5. Right? Cosine is adjacent over hypotenuse. Okay, now let's do this one. Cosine of B is 4/5. So I draw my angle B. Cosine, we just did that, that's adjacent over hypotenuse. So adjacent side I put 4, hypotenuse I put 5. That makes this opposite side also 3. Okay, so they're actually both the same triangle, 3, 4, 5. All right, and I need sine of B. See, what do we need the sine of B for? I have to plug into all of this stuff. Okay, so sine of B is opposite over hypotenuse, 3/5. Okay, so now what do I have? I have sine A, cosine B, sine B. I just plug into here, and then I'm done. Because ultimately, I'm trying to find a cosine of A plus B. By formula, cosine A, cosine B minus sine A, sine B. I have all these guys now. Okay, so I just pick them up. Cosine of A plus B is, by formula, cosine A, where'd it go? Cosine of A is 4/5. Then times cosine of B, which is also 4/5. Minus sine of A, 3/5. Times sine of B, also 3/5. Okay, so that's 16 over 25 minus 9 over 25. Final answer is 7 over 25. Okay. So it's definitely a little bit harder. All right, 37 is a little bit more complicated. Show that arcsine of negative x is the same as negative arcsine of x, where absolute value of x is less than or equal to 1. Okay, you don't really have to worry about that. Okay, you can only take the arcsine of something between -1 and 1. That's what that's all about. So how am I going to tackle this? I'm going to temporarily call this theta. Okay. See, quite often if there's something that you don't like, name it something, then maybe you can unscramble it. I can get rid of the negative. I can get rid of the arc, maybe. Let's see. So I'm not even going to touch this yet. Let me call this theta. Theta is arcsine of negative x. Okay, rewrite it without the arc. So sine of theta is negative x. Multiply both sides by -1. Negative sine theta is equal to x. Okay, now we know that the sine is an odd function. Property of odd functions is negative sine theta, you can think of as sine of negative theta. Okay, so sine of negative theta is equal to x. So that's as much as I'm going to do on this one. In other words, I'm finished with this. I've established that sine of negative theta is x. Okay. Now let me work on the right-hand side. Negative arcsine of x. I'm going to call it, say, A. So negative arcsine of x is A. Multiply both sides by -1. Arcsine of x is negative A. Rewrite it without the arc. So sine of negative A equals x. Okay. All right, so take a look at this. I have sine of negative A equals x. Sine of negative theta equals x. Okay, one more time. X equals that. X is also equal to that. That means these two have to be equal to each other. Sine of negative theta and sine of negative A have to equal each other because they're both equal to x. Okay. So sine of negative a equals sine of negative theta. That means negative a is equal to negative theta. Well, if negative a equals negative theta, multiply both sides by -1. That means a equals theta. And what were the original a and theta? Theta was arcsine of negative x. A was, I call it negative arcsine of x originally. Okay, so there it is, arcsine of negative x equals negative arcsine of x. Okay, it's a little bit tricky for that one. Okay, then 39. Show that arc cosine x is arcsine of radical 1 minus x squared, x between 0 and 1. Okay, usually you don't have to worry about this. Okay, arc cosine x equals arcsine radical 1 minus x squared. Okay, so I'm going to call this A. A is equal to arc cosine x for whatever reason. Okay, arcsine radical 1 minus x squared. Okay, I'm going to call this whole thing theta. So arcsine radical 1 minus x squared is equal to theta. Okay, so arcsine radical 1 minus x squared is theta. Write it without the arc. Am I taking the sine of radical 1 minus x squared? No, I'm taking the sine of theta. So sine of theta is radical 1 minus x squared divided by 1. Okay, sine is what divided by what? Opposite over hypotenuse. So theta, opposite hypotenuse. Do your Pythagorean theorem, you can show that this is equal to x. Do your a squared plus b squared equals c squared. Okay. So I'll let you try that on your own, but I can verify that. What is this thing squared? 1 minus x squared. What is this thing squared? X squared. So if you add them up, you have 1 minus x squared plus x squared. X squared cancels out, you get 1, which is equal to 1 squared. Okay, so what's the cosine of theta? Cosine is adjacent over hypotenuse, x divided by 1, which is x. Okay, now let's look at arc cosine x, which I decided to call A, which means cosine of A is x. So cosine is x. Remember, that's like x over 1. So cosine is what divided by what? Ca, adjacent over hypotenuse. So adjacent is x, hypotenuse is 1. You can do your a squared plus b squared equals c squared. This is radical 1 minus x squared. You take a look. Hey, these are the same triangles. If these are the same triangles, look at this. X, x. Radical 1 minus x squared, radical 1 minus x squared, 1 and 1. Okay? If these are the same triangles, what does that mean about the angles theta and A? Well, they got to be equal. A equals theta, which means going back to here, arc cosine x equals arc sine of radical 1 minus x squared. Okay. So that's a proof that the left-hand side and the right side are equal. Okay, then all I have left is 43 and 45, and I'll be done. So I'll be done in a few minutes, folks. And so if you have any questions you want to ask, bring those up. Otherwise, we'll be done very shortly. Okay, and it looks like I will be done with what I was going to show you for 4.8. Okay, so again, then we just have 4.9. I got all of next week to do 4.9. Okay. Okay, so let's see, 43. Okay, tangent of x squared minus tangent of x minus 2 equals 0 between negative pi over 2 and pi over 2. Okay. Tangent squared x minus tan x minus 2 equals 0 from negative pi over 2 to pi over 2. Okay, this is a quadratic equation in tangent of x. Okay, if you pretend tangent of x is a variable like y, it looks like y squared minus y minus 2. And then you factor it. So I put tangent x here, tangent x here. How do I get 2? 1 times 2. And you want to end up with a negative tangent. So that means the negative goes with the bigger number, negative 2, positive 1. Double check with FOIL. That's what all that red stuff is. First, tangent squared x. Outer plus tangent x. Inner minus 2 tangent x. Last minus 2. All right, so that means either this one is 0 or this one is 0. Tangent x minus 2 equals 0. Tangent x plus 1 equals 0. So move the 2 over. Tan x equals 2, which doesn't have a nice solution. We just have to get that on our calculator. Tan x equals negative 1. Okay? So when is a fraction equal to negative 1? Tangent is sine over cosine, right? Well, the numerator and the denominator are opposites. That happens at negative 45 degrees because the ordered pair here is radical 2 over 2, negative radical 2 over 2. So I take sine over cosine, which is what tangent is. Sine over cosine, I get negative 1. So one angle is negative pi over 4. This one you have to use your calculator, it says. Okay, so tangent of x is 2. Solve for x. Well, x is inverse tangent of 2. It's like you take the inverse tangent of both sides. So that says the same thing as this. Right? If you were to unscramble this, you would say tangent of x is equal to 2. And that on a calculator is 1.107. Make sure you are in radian mode when you do that. Okay, let me see if I can get that myself for you. Yeah, so I'm not sure you can see that, but see if I can make this darker for you. That's a little bit better. Let's see if I can make it still darker. But definitely you want to try it on your calculator. Inverse tangent of 2 in radian mode, 1.107, blah, 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 blah. Okay, so I rounded it up to 1.107. Okay, and again, for that one, make sure that you're in radian mode. Okay, 45, and then I'm done, folks. Then I'll let you ask questions, and if not, we're finished. So, 45. A lighthouse is 4 miles from a straight shore, as shown in the figure. Lighthouse, theta, 4 miles, x. If the light from the lighthouse is moving along the shoreline, express the angle theta formed by the beam of light and the shoreline in terms of the distance x. So write an equation for theta. Here's theta, x, 4. Now, with respect to theta, this is the opposite side. This is the adjacent side, right? So I'll essentially show you the picture. I'm not going to draw the lighthouse and the water and all that stuff, but I've got theta, x, and 4. Theta, x, and 4. Okay, opposite, adjacent. Which trig function involves opposite and adjacent? Tangent, TOA, T-O-A, right? So tangent of theta is x over 4. Solve for theta. Well, to solve for theta, you just do inverse tangent, right? So theta is inverse tangent of x over 4. And that's my answer. And we're finished. All right, folks, so I'm actually done with 4.8. So I'm back being ahead of schedule, so to speak. Okay, so I just have 4.9 left. That's all we have until the exam. So tomorrow I'll introduce 4.9, but I wasn't going to do any problems with it. I still got Monday, Tuesday, and Wednesday for that, so we got plenty of time there. Okay, and then I'll give you plenty of time to do the quiz also. So you might have the double angle formulas and the half angle formulas, right, for tomorrow's quiz. All right. Okay, so let me stop the share and see if anybody has any questions, and I'll check the chat. Okay, so you're ready. All right, so anybody want to ask me any questions? And if not, that's fine. Let's see. Okay, Miss Matter 79, or which one is it we did? Okay. But we did it yesterday. I think you can get it off the video, I believe. Yeah, I don't have that with me now. But yeah, as always, if you missed any part of the lecture, you can always look back at the video, and the video should be able to get that for somebody who put that in the chat. Okay, so 7 and 9. Well, we do have time. 7 and 9. Yeah, I can show you a little bit of it now since we have some time. Okay. 4.8, 7, arctan of radical 3. Okay, I can do that quickly. So let me go back to try to share the screen. Arctan of radical 3, number 7. Okay, call it theta. You write it without the arc. So tangent theta equals radical 3. Okay, tangent is sine over cosine. So sine theta over cosine theta equals radical 3. And I'm going to write it as radical 3 over 1. Okay, and then the trick is to divide top and bottom by 2 because it works. Okay, that's the only explanation I can give that it works. So when I write it like that, that means sine of theta is that, cosine of theta is that. Sine of theta is radical 3 over 2. You just equate that with that. And cosine theta is 1/2. Okay, so I draw my unit circle. Notice I'm not very accurate. I'm just freehanding this. Cosine x coordinate is 1/2. So I go halfway across like that. And for this one, it came out positive, so I want this one. So this is 1/2 comma radical 3 over 2. And you eyeball it. Okay, that looks like a 60-degree angle. It's more than 45 degrees. Okay, so theta is 60 degrees, which in radians is pi over 3. Okay. And yeah, number 9 we just did. Well, almost. Arctan of -1. All right, so call it theta. Tangent of theta is -1. And I was saying, when is a fraction equal to -1? When the numerator and denominator are opposite. Sine of theta over cosine theta equals -1. Okay, that happens at negative pi over 4, right? Okay. So this is radical 2 over 2, negative radical 2 over 2. Okay, they're opposites of each other. So when I take the ratio, I get -1. So that's number 9 there. Okay. Okay. How do you know when to divide by 2? Right. So it's only when you get situations like this. It tends to happen a lot when you do tangent or cotangent. So okay, so you should recognize the 1/2 radical 3 over 2. So if you ever see, especially with tangent or cotangent, if you get radical 3 or 1 over radical 3, that's often when you do the trick. Okay, so suppose I get cotangent x equals 1 over radical 3. That's a good idea to do, because if I divide top and bottom by 2, I get the numbers that I quote unquote like, 1/2 and radical 3 over 2. So then you would say cotangent is cosine over sine. So 1 over radical 3. And you say, well, what happens if I divide them by 2? And you say, aha, I get the 1/2 and radical 3 over 2 that I like. So cosine of x is equal to 1/2. you basically set these equal and set these equal. Cosine is 1/2, sine is radical 3/2. Okay, so it tends to happen more when you have cotangent and tangent. Okay. All right, I think I'm caught up with the chat we see there. Okay, anybody else? Otherwise, we're done, folks. Anybody else? All right, so have a good day. Tomorrow I'll introduce the last section, and then I'll give you the quiz for the rest of the time. All right, bye, everybody. Have a good day.